So, welcome back, guys. I just want to go over the quiz review sheet before the quiz for tomorrow, work out some of the answers with you. So, we'll start off with this first question. You're going to look at the degrees for each of the terms. You want to look at the leading terms. Sorry to zoom in just so you can see it a little bit better there. So, if we look at the first one, hopefully you have a copy of this on your own. You can probably look at the numbers. It's a little tough to read. But if we're going to look at the leading term, that would be a 1/3 right there. So in that case, if we're going to write out the decimals, the degree would be a degree of 0.33 repeating. In the next example, if we look at the leading term, you can see it's a fraction of 5/4. So this would be a degree of 1.25. If we continue down the path, this is obviously given to be a degree of 0.47. So we have that degree right there, 0.47. This is the highest degree right here. We've got a second degree, but because of the negative, it's going to be upside down. So even though this is a degree of 2, it's in the negative direction. So if we were to sketch that out, it would be something like this. And then the last example, it's an exponential function. So this obviously dominating the function, but the graph would be decreasing as you go to the right. And so since the question is saying which of the following functions has the largest values, but it's saying as x approaches positive infinity. So this means as we're going to the right, the leading term is going to dominate. And in that case, the leading term with the highest power is going to be choice B in this case. So choice B would be the answer to number 1. All right, number 2 brings us up to polynomial functions. This is what we've been working on the last few days this week and the last couple days last week. So a couple things about connecting the picture to what they're asking about. So if you look at each of the roots, if we highlight the 3 roots, okay, we've got a root here and a root here and a root there. Each of those roots kind of slice right through the x-axis. So they're each single roots. Okay, so we have single roots at 3 spots. Okay, so here we have x equals -1, here we have x equals 0, and here we have x equals +1. So those are your 3 roots right there. So since there's no double roots or any multiplicity of roots, there's no imaginary roots, since there's no bumps or turns off the x-axis, this is going to be a 3rd degree. So the first answer, 3rd degree. The zeros we already went through before, so these are going to be at x equals -1, 0, and +1. And then these 2 questions are asking, where is it greater than 0? That means where is the function positive? And where is it less than 0? Where is the function negative? So positive would be above the x-axis, negative would be below the x-axis. So I'll do these in a highlighted color. We'll take care of the positive sections. They would match on the graph from here to here, and also from here on to infinity. So if we're writing those intervals, it's between -1 and 0. So between -1 and 0 for your values of x, and also everything bigger than +1 as you go to the right. Okay, so everything as you go up through there. In the less than 0 category, that's everything below the x-axis. That's going from here and also there. So if we wanted to write out those 2, we'll do that in orange right there. So these 2 intervals would be everything less than -1 for x, so x less than -1. And also we have this little interval here between 0 and 1. So everything also between 0 and 1. So those would be your 2 intervals for where it's positive. A possible equation, well, each of these 3 roots up here are going to create factors. So this root at -1 creates a factor of x plus 1. Remember, it's x minus the root, so x minus -1 is x plus 1. We also have a root of 0, so technically that's x minus 0, so that's just x. And then the last one is a +1, so that's going to be x minus 1. And then remember, there's always that coefficient in front here, but in order to solve for that coefficient, we would need another coordinate to plug in for the x and y values to solve for that equation. So for now, a possible equation would be this equation with any positive leading term. All right, then going to the last one, the power equation. This behaves a lot like when we solve for exponential